Hello and welcome back to Machine Learning. I'm Javita Christie. And in this video, we are going to talk about how to implement a neural network using TensorFlow and Keras frameworks. So these are the two frameworks that are available in Python. There's, of course, others, but these are the two that we're going to be using in our videos. Those are TensorFlow and Keras, and we are going to import them like this. So we'll import TensorFlow STF, and then from TensorFlow, we are also going to import Keras like this. Okay, so let me just run this cell. And while it's running, let me also again mention that this is Google Colab, where I'm doing all my coding. If you have a version at home in your computer, Jupyter Notebook or Jupyter Lab, then you might have to install TensorFlow if it's not already available. So to do that, you would have to go to the command prompt and then do pip install TensorFlow if it's not available in your machine. So it depends on how your machine is working, where you are using Jupyter Notebook. If you're using it in Google Colab, you don't need to install it. You can just import it and you'll get it. Okay. Now the data set that we are going to be using is a TensorFlow built-in clothing data set, which contains images of 60,000 different clothes. And all those images are having certain labels. So the label 0 is for t-shirt or top, label 1 is for trouser, label 2 is for pullover, label 3 is for dress, 4 for coat, 5 for sandal, 6 for shirt, 7 for sneaker, and 8 for bag, and 9 for ankle boot. So all these clothing items are there, and there are 60,000 images. And that is the data set we will be using for building our model. And this data set is already present in TensorFlow, so you don't need a link. You don't need to have a CSV file, GitHub link, or anything. You can just get it from TensorFlow library itself. Now, to get the data set, just like we always do X-train and Y-train, we split our data set for training and testing purposes. So in a similar way, here also we have to split our data set. So we are going to take, there are about 70,000 images given in the data set. So we will take 60,000 for training, and we'll take the 10,000 for testing or validating our model. Okay. So you can see here that I have provided 4 variables, just like we used to do in normal machine learning algorithms. We used to use the train test split function and used to provide 4 different variables. So in a similar way, we have 4 variables here. X-train is the image data for 60,000 different clothes, which we will be using for building our model. And this data is in pixel format. So you cannot basically see the image, but you can read the pixel values and know that. So it will be kind of a matrix. And you will know from the pixels what kind of an image can be formed. And then we have the Y train. So Y train is the clothing type, which means this label from 0 to 9. And this will be used, this is associated with X-train. So all the labels associated with X-train are stored in Y-train, which also we will be using for training our model. XVal contains about 10,000 clothes images, pixel images, which we'll be using for testing or validating our model. And YVal contains all the labels associated with XVal for all this clothing, and again, that would be used for testing or validating our model. Now, to actually get your data, you just have to write keras.datasets.fashion_mlist, because that's the name of the data set. And because it's already available, you can just do .load data and you get all the data into these 4 variables. So you can see here that it is available. Previously, it was showing something like download. So if you are running this code for the first time, you will also be getting some message like that, that it's downloading because it's not available yet. But because you did load data, it's just going to download and attach it with your notebook. So that is why it was showing downloading earlier. Now the next step is to pre-process because we have to make our data set fit to be modeled using a neural network. So we are going to do some pre-processing. So specifically, we are going to do one-hot encoding. So what is one-hot encoding? It works like this. If you have data like this, so this is a one-dimensional array containing 1, 2, 3, and 1. You can convert it into two-dimensional array and just see how many values you have. So I have 3 unique values, 1, 2, and 3. So this will be a matrix, which will be a 3 cross 3 matrix like this. Okay. And sorry, it will be a 4 cross 3 matrix. So there will be 3 columns and 4 rows because we have 4 values. And this is the first row, which contains 1, 0, 0. Because my first value is 1, so in the first value here is going to be 1, everything else will be 0. Because this first thing represents 1, the second represents 2, the third represents 3. So since my first value is 1, we make the first position 1, everything else 0. Then you have 2. So we will make the second position 1 and the first and last 0. And then we have 3. So we will make the first 2 zeros and the last position 1. And finally, we have 1. So we will make the first position 1, everything else 0. So this is what one-hot encoding is. And we are going to be applying it to our model as well. Okay. Now, as you can see over here in the preprocess function, so this is a function that I'm going to apply later on. So I created this function, and what we're basically doing is we're taking x and dividing it by 255 because you know, if we just want to create images of 255 pixels, which is why there's a division here. And we are also casting it to a float data type. So this will, x will be a float, and we are casting y to be an integer because, you know, y is labeled 0, 1, 2, 3, 4. We don't want that to be decimal value. So that's what we have done here. And then we're going to use this function in the create dataset function. So what this function basically does is it takes some values of x, some values of y, okay, and the number of classes are 10. That is fixed because we already know there are 10 classes from 0 to 9. There are 10 different labels. And then the first thing it's doing is converting all the y values into one hot encoding, okay, where we are passing the depth as n classes, which means it will create this kind of a matrix for all the y values, okay, and it's going to return the data set to us from tensor slices. Now what happens here is we convert our data into a batch of, you know, certain images, number of images. So here we have selected 128 as our batch. So that means we will get our data set in chunks of 128 because it will help us later to train our neural network. So that's why we are dividing it into batches. We are also shuffling it because we don't want our data to be just like that. Remember when we were implementing any of the machine learning algorithms, we were not using it just like that. We were trying to use a random state and shuffle up the data. So similarly here we want to shuffle the data, which is why there's a shuffle function. And the map function will simply apply the pre-processing to all the x and y values. Now to create our data set, to apply all these functions to our data set, we are going to do it in 2 parts because we have 2 different data. One is training data, another one is validation or testing data. So here you can see we have a variable called train data set where we are going to apply this create data set function And we will be passing X and Y train, as you can see here. And what we get as a result is this modified pre-processed data set. And we'll do the same thing for validation. So again, we are passing X val and Y val, and whatever is the result gets stored in the validation data set. So let me run that as well. Okay. Now let's talk about building layers. So the network that we are going to build here is going to have 5 layers. So we are going to create it in this manner using Keras. The first layer over here, which you can see, which is the reshape. And also you might notice here, I have written Keras dot sequential. What that basically means is that it's a sequential model. Um, and a sequential model just processes data in a sequential manner from starting to ending. So it will be basically a model that flows in the same direction. Okay, so that's why we're writing Keras.sequential. Next, we are going to create all the layers. So the first layer, to create a layer, you just have to write Keras.layers, and then we will decide what kind of layer it will be. So the first layer is going to be the reshape layer, which will convert my my data into whatever kind of input or output you require. Okay, so it's going to convert that. Now, first layer is reshape, which is called input layer. It takes care of converting all the input data for all the layers below that. Okay, and our images are 28 by 28 pixels. Okay, so that means there are 784 pixels in all. So we are just converting all our 2D 28 by 28 arrays into a 1D 784 array. So that's what we are doing in this step. Okay, so the input shape is 28 by 28, so 28 comma 28, okay, pixels. So 28 rows, 28 columns of pixel values, and the target shape is just 28 star 28, which is 784. So this means this is one dimensional and this is two dimensional. So we are converting our two-dimensional array into a one-dimensional array in the first layer, and then this will be used by all the other layers. Now the next layer, they are all written dense, so you can see that I've written dense. So dense means that they are all very much interconnected. Okay, so it has a dense connection, which means every layer is very much connected with the next layer. Okay, now you might also notice there's a parameter called units. So units shows you how many total neurons you want in that layer. Okay, so here in the first layer we have 256, the second layer has 192, then we have 128, and then 10. And there's also activation. So activation is nothing but the activation function. In our previous videos, we have studied different types of activation functions. And in this case, we have all these activation functions available to build our layers. And you can use any of them. If you want, you can, study them before using them if you like, or you can just use them by understanding their properties. So these are the activation functions used for all the layers. We're not going to get into the details of what all these activation functions are. I think we have studied RELU, but we have not studied softmax in our videos, but you can check it out. And what does the activation function do? It decides whether the opinion of a particular neuron in the layer should be taken into account and up to what degree. Because we know that in a neural network, the data passes from one layer to another layer only when the activation function is activated. Okay, so, and notice that in the last layer, we have 10 neurons because we have 10 different kinds of clothing, right? We have labels from 0 to 9. So for any output layer of the neural network, the number of neurons will be equal to the number of classes that you have in your data if you're performing classification. So this is a classification type of question. And because we have 0 to 9, 10 different labels, that is why we are having 10 neurons in the output layer. And the function we are using is softmax. So let me run that as well. Okay. Next, we are going to go ahead and train our model. So to train our model, this is a very small code here. Now, there are several things here that I need to explain before we actually use this code. So the first thing is the optimizer. First of all, you have to do model.compile. Model is the variable we created here, okay, with all the 5 layers. And here we have model.compile where we are actually going to train our model. And to train our model, we are going to use the Adam optimizer. What does that mean? It is an optimizer that uses 2 gradient descent methodology. Okay, so it's going to use 2 gradient descent methodology. I'm sure we did covered this in backpropagation. What is gradient descent? And you must have studied that in high school mathematics as well. So this is just an optimizer that uses gradient descent. It is basically used to calculate the error. So there's also a loss function involved. In this case, it is called categorical cross entropy function, which is going to predict how much error will be there in the neural network. Okay, and there's also metric. So we have mentioned as our metric that we want to calculate the accuracy of our model, as use that as a performance evaluation measure. So that's why it's accuracy. Next, we are going to fit our model. So this fitting part is where actually the model gets trained, and we are going to do train dataset dot repeat because we want to go on training the dataset in different iterations. We don't just want to stop with one iteration. And we can specify how many iterations we want by writing epochs. So in epoch, we have written 10, which means there will be 10 iterations. In each iteration, there will be 500 steps. So these are the 500 steps per epoch. Usually, if you have 20,000 images and a batch size of 100, then each epoch should contain 20,000 by 100 images. Now we have 60,000 images, and we declared previously that we want a batch of 128. So ideally, you should be doing 60,000 divided by 128. We could do that calculation here. So that is 60,000 divided by 128. So we have 465.75. That is our ideal size. You don't have to go with this exact size. You could use your own. So 500 is pretty close to that. So we can use 500 steps per epoch. And the validation part simply shows how the validation or testing is going to be done. So for that as well, we are going to have repetitions. And here we have mentioned that we want 2 steps of validation. Let me run this code because this will show you exactly how it's working. So it will show you epoch 1, all the 500 different steps with the accuracy that is obtained. Then epoch 2 with again 500 different steps and the accuracy. You might notice that it's going to increase a bit every time, or sometimes it can decrease as well. What matters is what you get at the end of 10 epochs. So it is right now at epoch 5, and eventually it will reach 10. So let's just wait. So you can see the accuracy variable over here. So the final accuracy, you can see how it is going on increasing every time. And you will see that the final one will be much higher. Okay. This cell is still running, so this is how this is how the accuracy is determined. If you probably run it again, you might get a different value of accuracy here. So it all depends on how randomly the data was taken. Once you have calculated all this, you can make predictions. So to do that, you just have to do model.predict and pass your validation data set and get all the predictions. So what this basically shows, if you print out predictions, you will notice it's an array. Okay. Now, because you have 10,000 images in your validation data set, it is going to give you an array where for each image, it's going to give you 10 different values. Okay. So those 10 values are nothing but the probabilities of that image being belonging to label 0, 1, 2, 3, and so on. So say, for example, you have the first image, which is maybe an image of a shoe or a bag. Then the bag is going to have a label of 8. So it's not just going to give you that label, it's just going to give you the chance of this particular item belonging to label 0, 1, 2, 3, everything. So it will say that, okay, this particular item being a t-shirt or top is the chance of probability of that is 0.01. Probability of this thing being a trouser is 0.02, something like that. So the one for bag might be the highest. That's how you can decide that this is the label that should go with bag. Okay, and if you want to find out, if you don't want all these values, but all you want is the label itself, then you can apply the np dot, which is available, this is a function available, argmax in NumPy, which picks out the maximum value from all these values. So you can apply that, np dot argmax. And here I've written predictions 0, which means it's just giving me the label which is most probable for the 0th item in my validation data set. So it gives me 2, which means that particular item in my data set is a pullover according to this model. So that is how this neural network implementation works. And I hope you understood all this. I'll be back with the next video. So I'll see you there, and thank you for watching.